Hi everyone. Are you pulling your hair out trying to load large Revit and Navisworks models into one of these devices? Well, this talk is for you. Today we're going to cover a new product called Resolve that uses the Forge services to load those large models into one of these devices. Let's go. My name is Michael Beal. I'm a developer advocate for Autodesk on the Forge team. And presenting with me today is Angel Say from the Resolve team. Thanks for joining us, Angel.
Great to be here.
So last year at Autodesk 2019, Angel and I presented our VR talk on this technology. We also put together a really cool VR demonstration on the Forge Expo floor. So this is where groups of people walked through a virtual space together, reviewing a yet-to-be-built hospital room. Now I know a lot has happened since then, so Angel, can you tell us more?
Yes. Since our Autodesk 2019 talk, we've had a bit of a naming change. Back then you knew us as Insight VR. Now we are Resolve. And today we'll be telling you about the technology behind Resolve that helped us massively improve the demo that we showed you last year.
So in this lightning talk, we're going to cover 3 learning objectives. The first one is an introduction to Resolve. What are VR meetings? What's the benefit of them? The second one is we're going to learn the difference between what a small sample model is and what a real model is, and how that's going to affect the limitations of the Forge ecosystem. So to kick things off, let's start with the first objective.
All right. So I'm going to show you a brief demo here of how Resolve works. It's powered by the Oculus Quest, which is the device you see on the screen there. It's a standalone headset, and you can bring in your Navisworks or Revit models or any of the 70 different file formats that BIM 360 accepts into a collaborative virtual environment. Once you host your model on BIM 360, all it takes is a click of a button like you see in the screen, and you can bring that model into a collaborative environment like you see here. And under the hood, we have a new engine that allows you to stream in data from these large models into a standalone device. And then you have access to tools like properties, dollhouse mode, you can sketch in the model, you can measure, and most importantly, you can be in there with your colleagues, even if they're halfway around the globe, or with a client who is in a completely different time zone. And now I want to cover a couple of the key features. So again, I want to emphasize collaboration. When you put on your headset and you enter the Resolve environment, you're going to see the other people in the project as avatars, and they don't have to be in the same room as you. We also have the ability to mark up the model using our sketching tools like you see here, and you can also sketch in 3D, so you can do more advanced sketches than what you can do on a 2D screen. You have access to measurement tools as well, and the measurement tool looks very similar to what you may already be used to working with in Navisworks. It's going to show you the shortest distance between 2 points, as well as all the perpendicular distances. I've also got BIM properties, and these all come into the collaborative VR environment, so if there's an element that I'm unsure of, I can click on it to get more information, and all the data from Revit or Navisworks will show up in my VR menu. Now I'm going to show you a video of how we connect with BIM 360 and the Autodesk Construction Cloud to produce a full circle workflow where we can follow up on issues after a VR meeting. So in this video, I put on my Oculus Quest, and then I jump into a Revit model. I spot an issue here that I want to call out, so I use Resolve's speech-to-text annotations to say something out loud, like, let's review this with the structural team, and then the microphone picks that up, and Resolve will transcribe it, and I'll tag the item in question, and I've done this all from within VR, just using my voice and hands, but when I'm outside of the VR meeting, I can now open up Revit, and with the BIM 360 issues integration, I can go right to the issue that I left in VR directly in my modeling package. And this also works in Navisworks as well, using the same issues integration.
So let's expand on that with a system diagram. All of these applications, Navisworks, Revit, BIM 360, and Forge Viewer, are part of a connected ecosystem. When I create an issue from my browser in BIM 360 or from a desktop product like Navisworks or Revit, I'm using what's called a DBID. Resolve also uses the DBID via the Forge BIM 360 APIs, making it part of this connected ecosystem. So now, stakeholders like architecture, engineers, construction, operations and maintenance a part of a connected workflow, and so it's much easier to add VR to your existing process. So, what sort of hardware do I need to get started?
That's a really good question. If you haven't tried VR in a while, it's gotten a lot easier to use. Pictured on this slide is the Oculus Quest 2, which was recently launched, and it's an off-the-shelf VR headset. It's completely standalone, which means you don't need a computer and you don't need any cables tethering you to the computer. So it's very easy for people to use, and it's also gotten very affordable. So the consumer edition of this device is $299, but there's also a business edition for $799 that comes with some added security and device management. And I want to reemphasize, this is a completely wireless device, so you can put it in a box, send it to someone, and everything they need comes in the box. They don't need to do any additional setup. And of course, with Resolve, now you also have software to use this device to bring your BIM 360 projects into a collaborative VR environment. Here's a diagram of the BIM 360 Autodesk Construction Cloud ecosystem, and you can see that at the bottom we've got Autodesk Forge, which lets us bring data in and out of the ecosystem. And so we consume model data using the Forge APIs. We bring it into our servers where we optimize it so that when it's in the VR headset, it's as smooth as possible, and then we show it to you in a collaborative environment. But we are not just consuming data, we're also pushing data back to BIM 360 using these Forge APIs so that, as Michael said, we can come full circle and create a fully connected workflow of bringing in model data and pushing back issues so that you can track these things across the entire building lifecycle. So now let's dive into how we took the AU 2019 demo and turned it into an application that's capable of handling very large models in VR. So let's dive into this journey. You might be familiar with the development workflow that starts with testing something on your local computer, and it works just fine with your sample data. And then you start giving it to more people on your team, and warnings start to crop up. But nothing's breaking just yet. And then you start handing it to more people, and that's when things start going a little haywire. And then finally, you ship to production, everybody gets their hands on it, and everything starts to explode. Something very similar can happen when you're working with BIM data. So to understand the journey that we went through, we're going to look at 3 different types of models, starting with your proof of concept model, which for most people is this Revit sample project, and then a slightly larger model that you might use through development, and finally a large campus or a stadium that is the type of model that you'll receive in production. And to understand where things start to break, we're going to look at a few components of a model. The first is triangles. Next we'll look at fragments, which is just a collection of triangles, and you use it to describe objects. The more fragments you have, the more draw calls you're going to have. This can put some strain on your CPU and your model viewer. Finally, we'll look at the properties bubble, which is a JSON file or SQL-like database that has all of the building metadata, and these can get very big. The bigger they get, the slower they are to parse as well. So let's start by looking at a lightweight project. Let's take the Revit sample project, which I'm sure a lot of you have used. The Revit sample project has 400,000 triangles. That's not a lot, and we're still in the clear here with 2 gigabytes of RAM on the Oculus Quest, so we have plenty of breathing room. It has 777 fragments, which isn't a lot, but it's not quite negligible. But with some batching, we can take care of this. The property bubble is about 0.2 megabytes. This is totally fine. It's a quick download, nothing to worry about. So this is the kind of project that you start developing your application with, and everything is fine and dandy, and you think it's working, but we have to keep in mind that the Revit Sample House is a very lightweight project. So let's crank it up a notch. Let's look at the middleweight type of project. This is a hospital model that's federated in Navisworks. It's got 9 million triangles in it. With 2 gigabytes of RAM, we're still fine. However, it has 95,000 fragments. So now we're getting to the point where you have to start worrying about how many draw calls you're sending to your CPU. The Quest can handle about 100 draw calls, so we have to reduce this by a factor of 1,000. So we're going to have to start to get clever here with what we're doing. The property bubble is about 8.2 megabytes. This should be a relatively quick download, but after decompressing, it can also take a while to parse. We're going to start to see some warnings pop up and hit some limits of our hardware. So what else can go wrong? A lot more. Let's take a look at the heavyweight project, which is this federated campus. In this model, we have 600 million triangles, we have 3 million fragments, and an 80 megabyte property bubble. This is when things start to blow up. With 600 million triangles, we are going to quickly run out of RAM. We need about 7 gigabytes, and we said earlier we only have 2. So we're out of resources here. We have 3 million objects in our scene. If you try to load that up in an engine like Unity or Unreal, it's going to get unmanageable. Our property bubble is at 80 megabytes, which is a sizable download. When it expands, it's going to be impossible to parse. So now we've reached our limits. We've maxed out all the resources, and things will actually start to blow up. Let's take a look at what happens. Your server starts to crash because some of this data is too big. Your customer's browser also starts to crash. You might have seen that WebGL symbol that says WebGL has crashed. That'll happen. Your mobile device won't be able to keep up, and we have to remember the Oculus Quest is basically a mobile device strapped to your face. If you're downloading this content over 4G or LTE, you're starting to consume a lot of your bandwidth. And we also run into issues with Forge APIs, like the model derivative or property endpoints. They start to exhibit some strange behavior that could break your application. And here, Michael can explain more about what's going on.
Right. Forge services, like the model derivative APIs, can start to show issues when dealing with large models too. And this happens in 3 areas: the file upload, file processing, and data querying. With the first one, file upload, this is no longer an issue with the new resumable APIs, so let's skip that. Next is file processing. When processing large files, our servers need lots of RAM, but we have to guess that up front based on the file size, and we call this right sizing. When we guess it wrong, the process crashes and we retry again and again until it times out. And from the BIM 360 dashboard, it appears like it's still processing for hours, which is not great. Lastly, there is data querying. The query endpoint, by default, has a limit of 20 megabytes, as seen here. With this flag bypass, you can query properties inside large models, but it can be slow to download, parse, and filter on the server side. And this is a limitation of the service, which we are addressing. With the feedback we get from customers like Resolve, we recently upgraded the Forge services to handle large Navisworks files. So now a 2 gigabyte Navisworks files takes about 18 minutes to process instead of 6 hours of retrial fail. You can find out more in this blog post. Also, look out for our new file format called SVF2, which has stable DB IDs, WebSocket access, and mesh instancing, all for handling bigger models in a browser. So, how does Resolve leverage Forge to handle big models? Well, one way is to use the fragment list file from the derivative service as a spatial lookup table. Resolve uses this to transfer only a section of the building, not the whole building. However, version 1 relied on BIM 360 to select that region beforehand. In version 2, things changed. To tell us more, here's Angel.
So with the latest version of Resolve, we went back to the drawing board, and instead of having people choose areas they wanted to see and downsize their models from BIM 360, we wanted to figure out how can we do that for them. And so the loop that's playing on the screen gives you a bit of a look at what's going on in the background of Resolve. We're basically querying what you're looking at and where you're looking, and we use that information to just render what you need to see on the fly. So instead of the user manually inputting from the BIM 360 viewer, it all happens in the background without you noticing, and the best part is it's all happening on the wireless Oculus Quest. So this has allowed us to handle really large files like the ones that we've talked about in this presentation, and all on the Oculus Quest. Right now, we are the only collaborative VR platform that can open such complex BIM files on these wireless devices without having to section them ahead of time, because as I'm sure you all know, that can be very time consuming. So we've come a long way since what we presented at AU last year, and we want to thank you all for tuning into our talk. If you want to learn more about Resolve and how you can get your BIM 360 projects into VR, you can head over to resolvebim.com.
And this ends our presentation. Thanks again, Angel, and we'll see you all next time.